So in week 7, we're talking about non-right triangles. So when we had a right triangle, we were able to use, we had this acronym, SOHCAHTOA, and we also had Pythagorean. Unfortunately, non-right triangles don't follow those. So in normal, we would have done the proof for this, but now I'm just going to give you this kind of recipe or algorithm, we call it. And it says the sine of angle A, notice A is a capital letter when we refer to angles, over side A is equal to the sine of angle B over side B, which could also be equal to the sine of angle C over side C. So these are proportional to each other. So what we're going to try to do here is solve for side B. So I need enough of these unknowns to set up an equation with one variable. So it looks like I know the sine of 50 angle A is to its side 10 as the sine of 30 angle B is to its side lowercase b. So many of you have learned different techniques to solve for b. I'm going to multiply both sides by b. So I have b sine 50 over 10 equals sine 30 degrees. Again, I'm solving for b, so I'm going to multiply both sides by 10 and divide by sine 50. So how do I get an answer for side b from this? You're going to need a calculator. Notice the calculator should be in degrees. So if I type in sine 30 times 10, I always like to have my values in front of my trig functions. And I'm going to take that quantity, and it says to divide that by sine of 50. So 50 degrees. And side B should be about 6.5. Side B should be about 6.5. So we're going to use a little estimation here. Angle A has a degree of 50, which produces a side of 10. Angle B has a smaller degree, so shouldn't its side be smaller? And that's kind of just how I will tell if it's in relation to that triangle. So that is the law of sines. You don't need to know the proof, and there's a couple problems for you to practice in WAMAT.